Okay, in section 6.2 we're going to look at an ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is constant. So notice that we have 2 points that, if we were to go from one point to the curve and then back to the other point, that distance, the two of them, as we went all the way around, would be the same number, would be fixed. Basically, this is different from a circle because it's more egg-shaped. We have it longer in one direction than in the other direction. And of course, this is more of a horizontal ellipse. You can have a vertical ellipse. The general form for an ellipse that's centered at the origin is x squared over a squared plus y squared over b squared equals 1. Please note that if a equaled b, then we would have the same formula as a circle, except we would go x squared plus y squared equals r squared. The figure with a cross-section, the axis is a0 and negative a0, so these 2 points. And then it's going to cross on the y-axis at these 2 points. So, if we look at an example, for instance, this one here, and again, since we have a different a and a different b, those are squared, so the square root of 36 would be 6. So notice that basically from the center, I went 6 to the left and 6 to the right. Underneath the y, I have 16, square root of 16, 4. Going up 4 and down 4. The 5 is actually right here, so this is only 4, and this is negative 4. Now, if I was to write this more in the form of like what you might see for a circle and multiplied everybody by the 576, you would end up with 16x squared plus 36y squared equals 576. Please note that the 16 and 36, see the 16 and 36 that we had there, so how they switched. This is not the standard form for an ellipse. An ellipse needs to look like this in its standard form. Now, if it is not at the origin, then it becomes y minus h x minus h and y minus k, in which the center will be hk. Again, opposite signs anytime we have them inside parentheses like that. It may be necessary to do some complete the squares. You might even have to complete the square twice. The foci, which you see here, you can find from c squared equals a squared minus b squared. If b is bigger than a, then you'll write it the other way. But you'll want this to always be a positive number when you do the subtraction. All right, so let us look at a couple of examples. So notice that there's no parentheses here, so there's no minus h minus k part. So we know the center of the figure is at 0, 0. Now that's not the foci, that's just the center of it. We'll have a equals 5, square root of 25, and b equals 2, square root of 4. Now, if you go to the book, they sometimes will switch A's and B's so that when you're trying to find C, you'll always have a positive number. I think it's easier if you just always keep the A underneath the X and the B underneath the Y, and therefore you always know that the A is going to be going left and right, and the B is always going to be going up and down. So I know that the center is there, but at the same time, it will go through, I'm going to call these vertices. They're not really vertices because they're not endpoints, but I know that plus or minus 5, 0 will be 2 of the points, and 0 plus or minus 2 will be 2 more points. that this ellipse has to go through. So basically I went 5 this way, 5 that way, 2 up and 2 down will be some of my points. So I'm going to go ahead and put them in. So we got one here, one there, and one there. I'm calling them the vertices for what we've got. So just like when we were doing circles for ellipses, I want you to have at least 8 points. Since this only goes up and down to 2, let's go ahead and pick halfway between that. So we're going to let y equal 1. So that means then we will have x squared over 25 plus 1/4, because it's 1 over 4. 1 squared is just 1. That equals 1. Subtract the 1/4 from both sides and multiply by the 25. And we're going to have, because when we subtract 1/4, that'll be 3/4, and then multiply by 25. And we'll end up with x squared equals 75 over 4. And therefore, when we square root both sides, we're going to have plus or minus about 4.3. So by letting y equal 1, we get plus or minus 4.3. So that means we have another point at 4.31, and then we have one at negative 4.31. Now, if this was true for y equals 1, it has to be true for y equals negative 1. In other words, just like for the circle, we have to have symmetry. Negative 1 squared is still going to be positive 1, and so we'll have 4.3 negative 1 and negative 4.3 negative 1. And so now we have 4 more points. And so let's go ahead and put those points in. We have 4.3, so about there, not quite halfway. And then we've got to go down as well. 4.3 and negative 1, so that'd be about there. And then we've got to go in the opposite direction, 1, 2, 3, 4, and again about 0.3 and about 0.3. And so now I have my 8 points. So let's go ahead and do a little bit of connecting the dots. And so, kind of like that. You might need to round it off a little bit so that it has more of an oval egg shape to it. Now, probably in this case, instead of picking y as 1, which was halfway between the y is positive 2 and 0, instead of about the 0, it might have been better to pick an x value somewhere in the middle so that I could have had something in here to try to figure it out. Now, we also need our vertexes. For our vertexes, we're going to have c squared equals 25 minus 4. In other words, that's a squared minus b squared, which is going to come out to 21. So that'll lead to, and of course the foci have to be along the major axis. So since the major axis, the 25, tells us the major axis here, we know that we're going to have the square root of 21 is a little bit over 4.5. So basically we're going to have plus or minus 4.6 and 0 for our foci. And so if I want to put those on, 4.6 will be, closer to there and there, like that. And so this one is at negative 4.60, and this one over here is at positive 4.60 4, and of course the center is in the middle. So there is a graph of what I would call a horizontal ellipse. Alright, let's look at a vertical one. Now, this one, however, notice that it does not have the form that problem 1A did, plus it's got negative 16x plus 2y, so I'm going to need to do some complete the square. So let's go ahead and group things. There's my x's, and then over here I have y squared plus 2y, and then let's put, if we move the 13, it'll be negative 13. So I have grouped everything. Alright, now remember, complete the square. You look at the term without the squared, so the x and the y, cut it in half, square it, add to both sides. Now in this particular case, since I have a 4, I really need to take that 4 out. So now that it looks like this. This one, however, I don't have to worry about, because it's just a y squared term, so y squared plus 2y, and then this one will have a plus 1, because over there I had half of 2 is 1, 1 squared is 1. Here, half of the 4 will be 2, 2 squared will be, so I'll have a plus 4 here. And then, of course, on the other side, I have to add it to both sides. So here it's 4, but it's a 4 outside, so 4 times the 4, that's 16. And then here it's just 1. So now I have that. Okay, so this is going to give me 4 times x minus 2 squared plus y plus 1 squared equals 4. Now, we still don't have the right form because I need a 1 to be here, so I need to divide all of that by 4. So if I have 4 over 4, that's just 1, so this one is going to end up over 1. While here, since there's nothing underneath and there's nothing out front, it's just a 1, this one's going to end up y plus 1 squared over 4, and then equals 1. And so now I have my form, my vertex form, if you will, or my center form. Since this has 2 of them, I should say my center form for the ellipse. My a is 1, whatever is underneath the x term, square rooted. My b is 2. So I can say then my center, the center of this will be at 2, negative 1. And I know I've got 4 points from this, up to, down to, or up 2, down 2, left 1, right 1. So I call these my vertices. So I'm going to have, from this center, I'm going to have 1, negative 1. And so that's 1 to the left. And then 3, negative 1, so that's 1 to the right, so 2 plus 1, 2 minus 1. That's the left and right. Now I got to go up and down, so I'm going to have 2 and then a 1. Negative 1 plus 2 will give me a 1, and then the other one will be 2 and negative 3, because I went down 2. Now in terms of my c squared is going to be 4 minus 1, which is 3. And so my c will end up being plus or minus the square root of 3, which is about plus or minus 1.7. So my foci will be at, let's see, I've got, now, since the B is bigger than the A, this one's going up and down, so my foci have to take the y term and go up and down. So negative 1 plus 1.7 will be at 2 and 0.7. And negative 1 minus 1.7 will be at 2 and negative 2.7. And so those are my foci. All right, we need 4 more points around the ellipse. So in this case, I'm going to go ahead and let y equal 0. That makes the problem simpler. I then end up with x minus 2 squared is going to equal, let's see, oh wait, I got x minus 2, and then that's going to be plus, since y is 0, 0 plus 1, 1 squared, so it's going to be plus a fourth equals 1. And so I'm going to subtract 1/4, that'll give me 3/4, and again, because that was over 1. And so I'm going to have x minus 2 equals plus or minus the square root of 3/4, and so x minus 2 equals about plus or minus 0.9. And so I'm going to have my other points as 2.90 and 1.10. And if that works for 0, which is 1 to the left, it has to also work for 3. And so by symmetry, we'll have 2.9 and negative 2, 1 minus those, and 1.1 and negative 2. So the x's are the same, but 0, which we plugged in 0 for that, and then we also plugged in negative 2, because negative 2 plus 1 would give me negative 1, but negative 1 squared is back to 1, and so those are my other points. Now this is not a very big one, but we have, let's see, first we have 1 minus 1, so 1 negative 1 will be here, 3 negative 1 will be there, 2 1 will be up here, 2 negative 3 will be down here, and then we have 2.9 is 0, so pretty close to there, and then here by symmetry, and here and there, and so not a very big football looking thing. Please make sure you round them off, not make sharp points of these things. Okay, and then the foci, 2.7, so it's about right there, and to negative 2.7, so about right there. Okay, and so again, that one's 2 and 0.7, and that one is at 2, negative 2.7 for our 2 foci. Alright, finally, what would this graph look like? So, if we squared both sides, that would give us y squared over 4 equals 1 subtract x squared over 25, which if I rearrange it, I have x squared over 25 plus y squared over 4 equals 1. Okay, which is just like what I had in part 1a. However, since we're doing square root, remember that a square root has only positive values. So that means it's just the top half of graph 1a. So there you have section 2.